Hi everyone, welcome back to A207 Data Communications and Networking. Congratulations! We are now at Chapter 9, which is the last chapter of this module. In this chapter, we discuss some common applications of networking. My name is Nuruddin, and with me is our A207 student Matthew Tan.
Hi everyone!
Up to this point, so far we have covered some history of networking, what makes up a network, the rules and protocols that govern how a network runs, and what a network can be used for. We now come to a discussion on the applications that run on a network. Matthew, as an example, what are the most commonly used apps on your handphone?
Well, I would say Facebook, Gmail, WhatsApp, Line.
And which of these do you use the most?
Facebook first, I guess, and Gmail.
Alright, these are examples of applications which are built to utilize the infrastructure provided by networks, both wired and wireless. Imagine having your phone data plus your work and personal laptop suddenly being lost all at once. Wouldn't that be a major blow, Matthew?
That's unthinkable these days.
So to start with, we should understand that email and internet browsing access, which have been the most common uses of a networked computer for years, are prime examples of network applications. These applications use HTTP for request-reply communications, which is a sort of extension of the stop-and-wait protocol. A communication is sent by the sender, which then stops and waits until a reply comes through before continuing with communications. This time, the communication is between a client, that's your computer or laptop, and the server, which will be the email server or the web server of the website that you are trying to access. Browsers like Chrome, IE, and Mozilla all use HTTP for browsing the web, and this protocol, if you recall, will start from layer 4 of the OSI ladder.
But how come HTTP is a layer 7 protocol and you mentioned that it starts from layer 4?
Well spotted, Matthew. HTTP runs via an application, namely your browser, but sitting below and enabling it are the layers beneath. I mentioned layer 4 because that is where software, in terms of applications and protocols, take over and ensure smooth delivery of network traffic. So in absolute terms, HTTP stays at layer 7, but the preceding layers have their role to play in ensuring that data, messages, frames, and packets all get through.
Thanks, I understand a lot better right now.
HTTP is used as the main browsing protocol, while SMTP is used for sending and receiving emails. Electronic mail, or email, is one of the oldest network applications and ensures that messages are sent to and from the correct sender and recipient and with accurate message data and security. The core idea of hypertext is that one document can link to another document, and the protocol, that is HTTP, and the document language HTML were designed to meet that goal. One helpful way to think of the web is as a set of cooperating clients and servers, all of whom speak the same language, that is HTTP. Most people are exposed to the web through a graphical client program or a web browser like Safari, Chrome, Firefox, or IE. URLs are the means of how information is retrieved from a destination by a client anywhere across the globe. At the same time, multimedia across the internet has been gaining widespread prevalence. For example, in Facebook, people regularly embed music and video clips. These require their own protocols to ensure that the video and audio remains smooth without clipping or chopping effects. Nowadays, Facebook, WhatsApp, Skype, and other applications offer internet dialing. This capability uses the relatively new VoIP protocol, which stands for Voice over IP. Next, we come to overlay networks. Since we already have a physical network, software can be used to create a virtual network of nodes linked by the internet. Facebook and WhatsApp are examples of these. In fact, the trend of cloud computing rides on the principle of overlay networks. It assumes that OSI layers 1 to 3 remain provisioned at all times, hence always on. Next, software applications create a network of users, rights, and traffic management to form applications which have worldwide reach regardless of location, time difference, and even their own physical network. And there you have cloud computing in a nutshell. Next, we have a very quick look at carrier networks. Cellular telephony is now in its 4th generation. The first generation, 1G, was designed for voice communication using analog signals. To provide higher quality that's less noise-prone mobile voice communications, the second generation of cellular phone networks, 2G, was developed. While the first generation was designed for analog voice communication only, the second generation was mainly designed for digitized voice. 3 major systems evolved in the second generation: DAMPS, GSM, and IS-95. The third generation of cellular telephony refers to a combination of technologies that provide both digital data and voice communication. Using a small portable device, a person is able to talk to anyone else in the world with a voice quality similar to that of existing fixed telephone networks. A person can download and watch a movie, download and listen to music, surf the internet, or play games, have a video conference, and do much more. The 3G concept started in 1992 when ITU issued a blueprint called the Internet Mobile Communication 2000, that is IMT 2000. Long-term evolution, LTE, marketed as 4G LTE, is a standard for wireless communication of high-speed data for mobile phones and data terminals. It is based on the GSM/Edge and UMTS/HSPA network technologies, increasing the capacity and speed using a different radio interface together with core network improvements. The standard is developed by the 3GPP, that is, Third Generation Partnership Project, and is in industry use as 4G Release 9. That sums up our discussion and the module A207 as a whole. Remember to post any questions onto Google Classroom. Work hard, work smart, work your way to your dreams.